With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let's start the question. It says in permanganate titrations, potassium permanganate is used as an oxidizing agent in acidic medium. So the medium is maintained acidic by the use of dilute sulphuric acid. Potassium permanganate acts as a self-indicator. The potential equation when potassium permanganate reacts as an oxidizing agent is given over here. That is given over here where we either produce 5 nascent oxygens or we consume 5 electrons to convert this MnO4 minus to Mn plus 2. So this is the principal reaction over here. Now before the end point the solution remains colorless, but after the equivalence point the only extra drop of KMnO4 the solution imparts pink color. That is, the appearance of pink color indicates the end point. Now these titrations are used for the estimation of ferrous salts, oxalic acid, oxalates, hydrogen peroxide, AS2O3, etc. Now let us move to the question. So the question over here is 10 ml of NaHCO3 solution is neutralized by 10 ml of 0.1 molar NaOH. Now 10 ml of same NaHC2O4 solution is oxidized by 10 ml of KMnO4 solution in acidic medium. So the molarity of KMnO4 is, and we have 4 options over here. This is A, B, C and D. So now let us first solve the question. Now if we see the reaction between NaOH and NaHC2O4, then this will be like this: NaOH plus NaHC2O4. Now this is a monobasic acid and this is a monoacidic base. Because this has only one OH minus, this has only one H plus. So this is OH minus and this is H plus. And the reaction will be like this. So we'll be having Na2C2O4 and along with this we'll be having H2O. Now as we can see, one equivalent of NaOH is reacting with one equivalent of NaHC2O4. So we can apply this relationship, that is M1V1 NF1 is equal to M2V2 NF2. This is the equivalent relation of titrations. So now here this side is for oxalic acid or sodium bioxalate, that is NaHC2O4, and this side is for NaOH. Now if we solve this, then here for NaHC2O4 the facts given are, this is 10 ml. So here this is M1 into 10 and the NF1 is 1 because this furnishes only one H plus ion. So this is 1 is equal to M2, which is 0.1 molar NaOH. So this is 0.1 M multiplied by V2 is 10 ml into NF2 is 1. So here we can cancel this 10 with this 10 and the M1 will come out to be 0.1 molar. Now we have the molarity of this NaHC2O4 solution is 0.1 molar. Now if we look at the reaction of this manganate ion in presence of acid, then this is like this. So this is MnO4 minus plus 8H plus. This gives, in presence of 5 electrons, this produces Mn plus 2 plus 4 water. Now if we look at the reaction of this NaHC2O4, so this is NaHC2O4. This will produce CO2 plus Na plus H plus, and here this will be by losing 2 electrons. And if we balance these reactions, then we have to multiply the first reaction with 2 and we have to multiply the second reaction with 5. So this is into 5. So the net reaction will be like this, that is 2 MnO4 minus plus 16H plus gives, and here we'll be having 5 NaHC2O4 NaHC2O4 gives, and here plus 10 electrons and minus 10 electrons will be cancelled, and here we'll be having 2 Mn plus 2 plus 8 water plus 5 Na plus and 5 H plus, 5 Na plus 5 H plus 5 carbon dioxide. Now we are having H plus on both sides, so here we can cancel this one, that is 5H plus, and here we can decrease 5H plus and make it 11H plus. So this is 11H plus. So now we have our final reaction, that is 2 moles of MnO4 reacts with 5 moles of NaHC2O4. So we can also write like this, that 2 equivalents of MnO4 minus reacts with 5 equivalents of NaHC2O4. So we can develop or set up another equivalence relation like M1 V1 NF1 is equal to M2 V2 NF2. Here this one side, or M1 V1 NF1 side, is for KMnO4, and this side is for the other one, that is NaHC2O4. NaHC2O4. Now in KMnO4, as we can see, the KMnO4 is gaining 5 electrons, so the N factor for this one will be 5, and the NaHC2O4 is losing 2 electrons, so this NF2 will be equal to 2. Now here we have already known or estimated the strength of NaHC2O4 solution, that is 0.1 molar. So here this is M1 that we have to find out. V1, as we are given in the question, this V1 is 10 ml, the volume of KMnO4. So this volume is 10 ml. M1 into 10 into NF1, that is 5, is equal to M2 that we have found out is 0.1 molar multiplied by V2. So here V2 is given as 10 ml, so this is 10 ml multiplied by NF2 is 2 for NaHC2O4. So from this equation we can find out M1, which is equal to 0.1 into 10 into 2 divided by 10 into 5. So this will be equal to 2 by 50, which is equal to 0.04. So the molarity of KMnO4 is equal to 0.04 m, and from the options the correct option is given in option number C. So option number C is the correct answer. This is the required solution. Thank you.
For class 6 to 12, IIT JEE and NEET level, Trusted by more than 5 crore students. Download Doubtnut app today.